First thing we're going to do is review the probability, which is just the chance that something will happen, right? You guys know this from elementary school. It's going to get more difficult than this, but just so you know, this is where we're starting. But if we have a spinner, has 1, 2, 3, and 4 on it, what is, and this is how it's the first vocab thing, the P here in parentheses means the probability. So if you see P with parentheses, you say, what is the probability of spinning a 2? So, and that would be, 1 out of 4 possibilities, right? And these are even possibilities because they're all equal size. So 1 out of 4, but with probability, your answer is always a decimal. Okay? It's always going to be from 0 to 1. So while we understand it as 1 out of 4, just know the actual answer to any question that says, what is the probability, should be a decimal from 0 to 1. And that's the same thing as percent, more or less, as from 0%. And the reason it stops at 1 is because the highest possibility of something happening is 100%. You can't have anything happen over 100%. You can't have anything happen, -%. So that's why the answer that you guys are given is always going to be some decimal from 0 to 1, right? Decimal form. And we usually round to the nearest tenths, hundredths, thousandths. Okay, 3 decimal places. What's the probability of spinning an odd? All right, look over here, and then there's 2 of them. So the probability, and here's how mathematically you solve this. Well, it's going to be the probability of spinning a 1, because that's an odd, plus the probability of spinning a 3. That's the other odd. Each of those is 1/4. So if you add them up, you get 2/4, which is 0.5. Okay. Again, we want a decimal answer. Your answer to any probability is going to be a decimal. 0.25 or 0.5 is fine. So this will be new to you, how you have to write this stuff out to keep track of it. Obviously, it's not necessary to write that out to get the answer for these. These are elementary school. This is the easy stuff. We're going to get into the high school stuff in a moment. That's going to be more involved. That you can't just look at, oh, it's this, right? So just know it's going to get a little more involved than what you already are familiar with. What is the probability? And these are typical questions you'll be asked for each problem. What's the probability you spin a 5? 0, yeah, because there's 0 possibilities over 4 total, so there's no chance, 0 chance. And what about spinning anything that's less than 10? Yeah, that means less than, right? So how many of these are less than 10? 4. So there's a total of 4. Therefore, probability is 1, or 100% chance that you spin something less than 10. So those last two are just to cover the 0 and the 100 or the 1 possibilities there. Okay. Now, we'll kind of ease into this right now. I'm going to introduce a few things here. But first of all, just look at the span of this one problem. Okay. We start off with this scenario. It has an A, B, and C. You have to make a histogram, and you have these 3 questions to answer afterwards. Okay. That can be good or bad depending on your attention to detail. Meaning, if you make a mistake, it's all easy and simple math. But if you make a mistake right here, that means B is going to be wrong, C is going to be wrong, and possibly D, E, F, and some combinations will be wrong because you just did something wrong at the very beginning. So that it's very small details that you have to be careful and not just rush through and get wrong from the very beginning. So first of all, sample space. Sample space is just what are the possibilities to choose from, kind of like domain. So think of sample space as what are the possibilities? What can you and what can you not have an answer of? Okay? So, and a lot of what you're going to be doing is reading a situation, right, and coming up with some sort of diagram that gives you all the possibilities. So here you have a spinner. You're going to spin it twice, find the sum, right, add them together of the 2 numbers. So What are the possible answers for this situation? Can you have an answer of 0? 1, 2, 3, 4, 5? No, no 5? So the highest you can get is 4. How many of each of those are possible? So how many different ways are there to get 0, to get 1, to get 2, to get 3, and get 4? Because we need to know how many possibilities there are to calculate probability. So you see, it's more than just what we did up here. Oh, there's one of them, so it's 1 out of 4. You have to know, well, how many. You can imagine a spinner like this, but there's a 1 here, a 1, like I guess I could do something like this, right? And there could be a 1 for several of these. And there could be a 2, there could be 1, 2, and there could be 3 3s, and maybe 1 4. There can be more than just a single location for each given number. So we want to be very careful and do this systematically and not just say, well, we can have 0s, 1s, 2s, 3s, 4s, and so on, but just say, let's say our first roll can be a 0, 1, or 2, right? And then we can have our second roll here can also be a 0, 1, or 2. Go. And do this very methodically, so we don't accidentally leave off of one possibility that we couldn't think of. So this goes through systematically here and says, well, if I roll a 0 first and then a 0 second, the rule is to find the sum of those. So 0 plus 0 is 0. And then what if I roll a 1 then a 0? 1. I roll a 2 then a 0. What if I roll a 0 then a 1? Right? You can kind of see this forming. Roll a 1, then roll another 1. It's 2. Roll a 2, then a 1. 3. Right? Roll a 0 and a 2. Roll a 1, then a 2. And then we roll a 2 and then a 2. 4. So we can see here there are 9 possibilities. This is important to know. That's the number that we had up here. It's easy to look at this and say, oh, it's out of 4. There's 4 possibilities. It's 1, 2, 3, or 4. We can see a spinner, very obvious. But in the higher probability, it's not necessarily obvious just by looking at and reading this, looking at this and saying, oh, there's 9 total. So we have to have these ways of writing it down to be absolutely clear. All right, so sample space. It says a list of sample space. Again, think of it like domain. This is what we did back before with domain, and we're going to do it here. Use these braces, and you just list all the possibilities here with no repeats. So, and least to greatest as well. So 0, 1, 2, 3, 4. So that's the sample space. And then we've been saying how this test might be a lot easier because the math is so less rigorous. But it's things like this that you have to realize for this answer, it's this. So if I ask you for the sample space and you just draw this, that's not the sample space. That's just something that helps you get the answer. So know what the actual answer is, just like up here knowing that the decimal must be your probability. Okay, so far so good. That's the sample space. Part A is done. Now we're going to create a probability distribution or a relative frequency table for each of these. I'll show you what that means. We're doing a lot of tables here. Not with pink, though. Nope. And do another one. Okay. And basically, we take all these, put them on the top row with some space. Leave a little space between. So our n here is how many? is how many numbers you're working with. So we're working with a sample space, 1, 2, 3, 4, 5 numbers, n equals 5. All right, what we're going to do is now write down the probability for each one of these. Probability of x. So what's the probability of getting a 0? All right, go over here, and how many zeros are there? 1. How many total numbers are there? 9. So probability is 1 over 9. Right? Which we do report as a decimal. So as a decimal, if you do 1 divided by 9, you get 0.111. Now we just repeat. Do the same thing for 1. How many 1s do we have here? 2 out of 9. Right. How many 3s? I'm sorry, how many 2s? 1, 2, yep, 3 out of 9. So it's 3 possibilities, 3 ways to get 2. You can do spin a 2, then a 0, a 1 and a 1, or a 0 and a 2. 3 possibilities. And we have, let's do black. And for 3s, we have 2. 2. And then for 4, 1 out of 9. There we go. And this is the key that we'll use for C and D, E, and F to answer everything else, which depends on A being correct. So everything leads to the next. C is a histogram, like a bar graph, right? With the y-axis here being these decimals, this probability here. So you can see the highest that we need to go or graph to is 0.333. So I'm going to go over here and look at my axes and figure out, well, should I do 0.1, 0.2, 0.3? Probably not, because I got a lot of space here. So I'm going to space this out and make every third square a tenth of a value here. And then so I'll go 3 squares, 0.1, 3 more squares, 0.2, 3 more squares, 0.3. And since I'm going by threes, the top will actually be 3 1/3, which is the 0.33. So that means this will all fit on here. And then you also want to look at the length there and see how long it is and see how many squares each bar should be in order to fit, my 5 categories here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I have 25, 26, so that means if I have 5 different numbers, they can each be a width of 5. 1, 2, 3, 4, 5. This will be the 0. 1, 2, 3, 4, 5. And this is the kind of stuff I was mentioning about math being different. 2, 3, 4, 5. Just doing this correctly so that everything is even, everything's spaced out, looks good. Looks do matter. So I want to give it the time to do that. And everything's labeled here. Let's see here. And now let's begin graphing. So my 0 is going to go up to just 0.11. So here's 0.1, so the 0 will be just above that. Right. And for 1, it's going to be at 0.222. So here's 0.2, so 0.22 will be straight edge is your friend in this case. 3, we have, or 2, we have 0.333. That's the very top. Okay. And for 3, we have back down to 0.222. And lastly, there we go. All right, then I'll put the vertical parts in here to make the histogram. Oops. There we go. Good. And you can kind of see that normal curve, how that bell curve could fit kind of right over this. If you started connecting these corners and rounded at the top, it would look like that bell curve. And if we found the median and the mean and things like that, they'd be the same. Yep. So there is our histogram. So now let's look at DEF. Find the probability that the sum is 2 or 3. So we want to find the probability of 2 or, which is the same as plus, probability of 3. Basically, just have to go up here and look at it. So 2 and 3. We're just adding those together. We have 3 over 9 and 2 over 9. So 5 over 9, right? Two over 9 plus 3 over 9 equals 5 over 9. Which equals? You might need a calculator on some of these. 5 divided by 9. And I'm going to put, some of you have this on your calculator, you hit mode, and it says the float. That's the how many decimal points you want it to round to. So I can go to 3. I always want to enter round to 3. And that way it'll just automatically round it for me. So 0.556. That's the answer. There we go. Find the probability of spinning a sum less than 3. So you can write it out this way. Probability less than 3 equals, and it helps to look at this. Look at what numbers are less than 3 of your sample space. 0, 1, and 2. So we're going to have, to find everything less than 3, it's going to be the probability of 0 plus the probability of 1 plus the probability of 2. And this is why you want to look at the sample space and see this, because if we're talking about, like, instead of a spinner, what if we're talking about a dice, like a die? Would it have a 0 on it? No. So you got to be careful and actually look at your work and see, well, for this problem, what should I do? It's less routine than you're used to, where you get like 10 equations and you do the same exact thing on all of them just for practice on arithmetic. With statistics, every situation could be different. One problem you could maybe ask me about, like, probability of getting a full house, and that's a 3 of a kind and a pair together. And the next problem we can ask you about a straight, which is not even like, you know, a full house. So you can't just copy and do the same things you did before, because it's a different problem altogether. All right, so probability of 0, 1, 2, and 3, 2, 1, 2, 3. So this would equal 6 out of 9, which is 0.667. You know what? It's true, but I noticed in stats books they do it anyway. I don't know why. Only in stats. It's kind of assumed that we know none of these are actual equals and they're all rounded, but yet they always use equal signs. That's only in statistics books. Very odd people. Yeah, let's just stick with the standard. I'm not going to disrupt that, but technically, yes, these are all rounded. So he's saying like every other time we have always done approximate when we started rounding, but it's just not the case on these for some reason. All right, last one. Find the probability that the sum is not equal to 3. So you look up here. When is it not equal to 3? 0, 1, and 2, and then 4. So we're going to have probability of 0, probability of 1, plus the probability of 2, plus the probability of 4. Everything in the sample except 3. 0, 1, 2, and 4. Now, here's something you'll notice in probability, and that is that you can use prior answers to help yourself out. So like up here, we just found out what the probability of 0 plus 1 plus 2 is. It's 6 out of 9. So we just did this in E, and we already found out it's 6 out of 9. So we don't have to actually go through and rewrite the whole thing, and then just throw in the probability of 4, which is 1 out of 9. So our answer is 7 out of 9. Comes out to 778. So look for this reusing of an answer. It will serve you if you kind of look for it. Now, you can be creative. You're in one of those higher math classes, as you've already seen. There's different ways of doing things. So someone else might look at this and say, well, what's the probability of all of these happening? Right? If I add up all of these, what's the probability? 1, right? So we know, because that means, well, there's a 100% probability something will happen, right? We know that for sure. If we want to find out the probability of something not happening here, like what's the probability of not getting a 3? We could just take 1 and subtract out that probability, and that would leave us with everything else. So for instance, to find out probability of not 3, I could find out, well, that's going to be the same as 1 minus the probability of 3. I'm just taking the 100% and removing the probability of 3 happening, which is 2 out of 9. And 1 minus 2 ninths is 7 ninths. Same answer. So there are different ways you can look at probability of just by brute force adding up the however many times this happens. Or we can subtract from 1, or 100% if that's easier. Now here it doesn't really make a difference. If we're talking about 1 through 100, and what's the probability of not getting a 17 or a 43? Well, it's a lot easier just to subtract probability of 17 and 43 from 1 and not add up 98 probabilities, right? So it depends on your sample size and how big numbers you're working with. One or the other might be easier or more convenient. Okay. So that's one problem. Okay. That's one problem. So this is the kind of stuff you're on. And if we went too quickly, rushed, didn't understand the question at the very beginning and got this table wrong, all of this would be incorrect as well. So you can say this is more simplistic, like, oh yeah, I can add a fraction, 6 over 9 plus 1 over 9, that's simple. But the work is really not in the math. The work is in the critical thinking of understanding, is what I'm writing down actually representing this scenario or not? Or are you just making something up because you're trying to just guess it, and that will not get you very far. So just be very careful with the very beginning and really make sure we understand it. Don't assume anything, don't make it up, and don't say, oh, it must be this because that's simple. Like, that's what gets you in trouble. So let's look at this different scenario. We're not adding them together anymore, so you throw out that was the first problem. Let's look at another problem. This time, see here, game involves rolling 2 dice, so you can imagine you and somebody else, you're each rolling 1, right? and your score is this. Or I don't know if you want to call it score, but the number you're going to put down is this, whichever one is larger of the two values. So if one of you rolls a 4, the other rolls a 5, what do you roll? What do you put down? 5. Yeah. One of you rolls a 1, the other one rolls a 2. 2. Yeah, the larger of the two values. You just pick, that's the answer, right? What if you roll a 2 and a 2? We keep reading. If the values are the same, the score will be the sum. So yeah, 2 and a 2 will be 4. So there's two different rules going on. And this is where you get the high school stuff where, yeah, you're not just going to add two numbers together for every problem. There's going to be different scenarios. Some of them might say multiply it by 3 or divide it by 2 if it's this. You know, you have to read the question carefully, make sure you understand it. So there's two possibilities. We get different rolls, different numbers when we roll. We just take the bigger of the two. No problem. We get the same number, we add them together. Now, with those two rules in mind, let's make that diagram that gives us all the possibilities. How many possibilities are we about to have right now, by the way, if we're rolling a 6-sided dice twice? Yeah, the last time we had 3. We had 3 choices, we spun twice, we end up with 9. So yeah, we'll have 36 possibilities here. So everything's going to be out of 36. Let's list it though, so we don't actually. We have to know how many ways there are to get a 3, 4, 5, 6, and so on. So here we go. We have our first roll is going to be 1, 2, 3, 4, 5, 6, and our second roll. There we go. And we have to keep these two in mind really carefully, right? We can't just easily fill this out like we did the last one. Definitely not like the first one that was super easy, 1 out of 4, you know. So if we have a 1 and a 1, what should I get? Okay. There comes the fun part. See who's been following along. If I give a 2 and a 1, what should I get? 2. Everybody see why? Right. We should actually do this way. 2. This is 2. So these are two different rules. Because the blue here underlined, if they're the same, you add them together. So 1 plus 1 is 2. But here, the 2 and the 1, the score is the larger of the two. 2 is bigger than 1, so 2 is the answer. What about 3 and 1? 4 and 1, 5 and 1, and you'll start seeing patterns. So just go with that. We can go down the first column as well. 2 and 1, 3 and 1, 4 and 1. What about 2 and 2? 4. They're the same, so we add them together. What about 3 and 2? Who wins? 4 and 2? 4 wins. 5 and 2? 6 and 2? Yeah, you can kind of see a pattern forming. 2 and 3. So go and just fill out the rest of this. You shouldn't have to look up anymore and see what the answer is. Just follow the pattern and watch out for when they're the same. Okay? Go ahead and do that right now. And then write the sample space below. Okay, so the sample space. This is where things kind of, you have to really trust your work here. You're looking at doing these problems that you're not used to, not familiar with. You can't just guess them as easy. So usually least to greatest in order, right? So our smallest is 2, 3, 4, 5, 6, 8, 10, 12. So there's no ones because you can't roll twice and get a, well, even if you both roll 1, it's a 2, and if one of you rolls a 1, you always lose if it's any other number. So it's impossible to get a 1. It's impossible to get a 7, it looks like. None of these add up to 7. We're getting an answer of 7, or 11, or 9. So you can see how it's not routine, like we can't just know right away, oh, there's n equals 1, 2, 3, 4, 5, 6, 7, 8 different possibilities, but by you making the graph, we can definitely see for sure. I'll give myself a little more space because this sample size is bigger here. So just copy that down. Give myself a little space. Write those decimals. There we go. And then our size here, we already said was 36. Right? So we know each of these is out of 36. We just have to be careful as we're counting right now. Make sure we get the right amount. And when we're finished, all the numbers should add up to 36. So we can do a check before we do the histogram, right? And make sure we did get all of them. And as you saw me doing before, I like crossing them off so I don't forget one. If I have anything left over when I'm done with this, I know I missed one as well. So for 2, there's 3 out of 36. And you will want to get the decimals for each one of those as well eventually. How many 3s are there? 1, 2, 3, 4. And 4s? 1, 2, 3, 4, 5, 6, 7. 7 of them. 5s? 1, 2, 3, 4, 5, 6, 7, 8. And 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the neatness of your chart right now will pay off. If it's all sloppy, the columns are going together, writing really small, it's very easy to miss like that 6 in the middle or that 4 in the middle because it's not by the others. If you write big, organized, neat, you'll be a lot less likely to miss something like that. And then for the last 3, they're each one of them, 1, 8, 1, 10, and 1, 12. All right. Now, add this up, do a check, and see, are you correct up to this point? This should equal what on top? That should equal 36. That means we have 100% of the possibilities accounted for. So we have 7, 14. 14 plus 8 is 22. 22 plus 11 is 33. And then 34, 35, 36. So I know for sure I've gotten all possibilities, 100% of them. And of course, we want to have the decimals for each one of these. It's 0.083. 1 out of 9, 0.111, 116. We need these because we need this to graph our histogram. 8 out of 36 is 0.222. 11 out of 36, 0.305. 1 out of 36 is 0.028. There we go. And these may not, the decimals may not add up to 0, not add up to 1 perfectly because of rounding. If we round it up or round it down too many times, we might end up with a 0.999 or a 1.001 or something. That's okay because it's just considered a rounding error. So we like the fractions because you don't get the rounding errors. That's why we keep them around. Otherwise, we just use decimals exclusively. Yeah, question? Okay. All right, so let's do the histogram. So our highest decimal here is like 0.3 again, so I can kind of use the same measure here. Go up to, like, this is 0.1, 0.2, 0.3. And my sample size is quite a bit bigger. 1, 2, 3, 4, 5, 6, 7, 8. I got to fit 8 of them here, and I have like 25, so I can do 3s. One, 2, 3, 4, 5, 6, 7, 8. There we go. 2, 3, 4, 5, 6. There we go. I'm using this chart right now, using these decimals. The 2 is 0.083, so basically, almost 0.1, but 0.08. And 3.111. And then 4.116. Oh no, I think that should be 6.166. 5, we got 0.222. I'm just estimating these numbers best I can. 0.2 is right here, so 0.222 would be right, above. It might be even up a little bit higher. This one would be 0.23. That would be the next line, so maybe 0.22 should be a little bit higher, but it's all estimating roughly. For 6.305, so it's up here. And 8.028, very small. I think it's the same for all these. There we go. There's a histogram. So it looks like it's skewed. It's not like the last one, which is very symmetrical. Bell curve fits perfectly. Would this be skewed right or skewed left? Skewed right, yes. And there's notes on the board on the left there at the bottom in the middle about the skewed left and right with a box plot and curve. So let's find the probability of scoring less than 5. I want to score less than 5. I can look up here. There's 5, everything less than it. It's 2, 3, and 4. Probability of getting a 2 plus probability of getting a 3 plus probability of getting a 4, which are 3, 4, and 7 out of 36. 3, 4, 7 out of 36. Comes out to, let's see, 7 and 7 is 14. And then 14 divided by 36. And 0.389. Which is, basically 39%. If you round that up a little bit, if you're actually talking to somebody and conversing about this, you wouldn't say, oh, it's got about 0.389%, chance. You'd probably say, oh, about 39% of getting less than a 5. What about scoring at least a 6? So what's wrong with this? Why is this wrong? Yeah, include 6, right? So some of this is English. We have to know that at least is greater than or equal to. Like if you ask somebody, can I borrow at least $20? It's $20 or more, right? Not just, it has to be, if I say at least $20, doesn't mean more than $20. So sometimes the English language and knowing exactly what it means can be the difference of getting the math problem right or wrong. What if it said at most? Yeah. At most is less than, at least is greater than. So sometimes people say, well, least is less. Least is less than, and more is more than, greater than. No. You have to think of it in real life terms. At least is $20 or more, right? So we want 6 or more. So we just look back up here. 6 or more, right? Would be 11, 1, 1, and 1. That would equal each of these added up. And I want you to write these out, even though it seems like, well, I know what the answer is. Like, well, you need to be able to prove it, number one. Number two, these are going to get more complicated. Get used to practicing on these easier ones, right? And that way, when they get more difficult, oh, I did something wrong. What did I do wrong here? I'll put us that. I'm trying to talk and think at the same time. See what happens with you guys? If you're over there talking right now, this is what happens. Start making mistakes. There is no 7. There we go. So we have 11, 1, 1, and 1. Out of 36, which just happens to be the same. So here's another thing we can do in probability. There is a way to figure out when things, when things are equal to each other. So for instance, see how both these equal 14/6? We could actually say, well, the probability of getting less than 5 is equal to the probability of getting 6 or more. And we can add more stuff on either side as we get into more complicated problems and start adding and subtracting on both sides, just like a regular equation. All right, so that's in probability and statistics. If you take that class, you'll get into that part of it. So that's where the equations and the math you've already known starts flowing into probability, because you can, get two probabilities that are equal and then start solving. Right, subtract on both sides, and since these are equal, it equals 0, and so on. About scoring a 5 or a 6. Scoring a 5 or a 6. That'd be these two, right? So we'll have probability of 5 plus the probability of 6. That equals 19 out of 36, which is approximately 0.528. All right, homework number 18. Let me show you on the board.